In this video, we're going to take a look at probability problems using combinations. So let's take a look at an example. So suppose you buy one ticket for King's Lottery. A person randomly selects 5 different numbers from numbers 1 through 30 inclusive. If your ticket matches all the numbers selected, then you will win the jackpot. What is the probability that you will win the jackpot? So what needs to happen? You need to have 5 correct numbers, or in other words, all the numbers need to be selected, and 0 incorrect numbers divided by the total number of outcomes. Okay, so there's 5 winning numbers and you're going to select 5 of them. That's a combination of 5 things taken 5 at a time times. Well, how many incorrect numbers are there? Well, there's 30 total. 5 are going to be selected, so 25 are not going to be selected. And you're selecting 0 of those. So that is a combination of 25 numbers that are not selected, and you select 0 of them, divided by the total number of outcomes. Well, there's a total of 30 numbers, and you are selecting 5 of them. Okay, a combination of 5 things taken 5 at a time is 1. A combination of 25 things taken 0 at a time is also 1. Let's put in the calculator the combination of 30 things taken 5 at a time. So we can put this in with the 30. And remember, that's math, prob, and then go down to NCR, type in the 5, hit enter, and we get that number here. So let's put that on our paper now. Okay, so that's our denominator, and of course 1 times 1 is 1. So here's our probability. Okay, let's take a look at the next example. So it's a lottery example again, but this time it's asking what is the probability that you will match exactly one number. So let's write this out in words. So this is going to be what? Selecting one correct number and selecting 4 incorrect numbers all over the total number of outcomes. So there's 5 numbers that are selected and you select one of them. That's a combination of 5 things taken one at a time. Now, remember 30 minus 5, that's 25. So 25 numbers are not selected and you select 4 of them. That's a combination of 25 things taken 4 at a time. And the denominator is exactly the same. There's 30 total numbers to select from and you're going to select 5 of them. Okay, let's put some of these into the calculator now. Okay, let's start with a combination of 5 things taken one at a time. So we know that's going to be 5. So now let's do 25 choose 4. So that's, remember, 25, then math, then highlight prob, go down to NCR, type in 4, hit enter. And we already know what the denominator is. We've already done that. So let's put these numbers on our paper now. So again, the 5 choose 1 is 5. Combination of 25 things taken 4 at a time is 12,650. Denominator is the same as the previous example. Multiply. We get this. Remember, I'm not going to worry about reducing this into lowest terms. I'm just going to leave it as that answer. Okay, let's take a look at the next example. So suppose that a shipment of 20 electronic components contains 3 defective components. To determine whether the shipment should be accepted, a quality control manager randomly selects 4 of the components and tests them. If 1 or more of them is defective, then the shipment is rejected. What is the probability that the shipment is rejected? Say, so this is going to be what? The probability that at least 1 component is defective. This is the same thing as 1 minus the probability that none of the components are defective. So that's going to be 1 minus. How do I write that? That means we're going to select 0 that are defective and 4 not defective, all over the total number of outcomes. Okay, so we know that 3 of the components are defective, and we're going to select 0 of them. So this is going to be a combination of 3 things taken 0 at a time. Well, if there's 20 total parts and 3 are defective, that means 17 of them are not defective, and we're going to select 4 of them. So this is a combination of 17 items taken 4 at a time, divided by the total. So there's 20 total parts, and I'm selecting a total of 4. So because this is a setup only, I'm going to leave this as 1 minus this particular fraction. Okay, let's take a look at some card examples. So suppose you are dealt 5 cards from a standard deck of cards, no jokers. Determine the probability of being dealt the following hands. So we'll start off with exactly 3 sevens. So what does that mean? You have 3 sevens in your hand and 2 non-sevens in your hand, divided by the total number of outcomes. Well, there are 4 sevens in the deck, and we're selecting 3 of them. So that is a combination of 4 sevens. We're going to select 3 of them. Well, how many non-sevens are there? 52 cards total minus the 4 sevens, that's 48. So this is going to be a combination of 48 non-sevens, and I'm going to select 2 of them. Divided by the total, well, there's a total of 52 cards, and I'm going to select 5 of them. Again, these are setup onlys. This would be as far as you would have to go. Okay, let's take a look at the next example. Exactly 4 black cards. So, what does that mean? 4 black cards and 1 non-black card. But you know as well as I do, that means exactly the same thing as a red card. But I'll try to keep the terminology similar. Okay, there's 26 black cards, 13 clubs, 13 spades, and we're going to select 4 of them. So 26 total black cards, I'm selecting 4 of them. How many non-black or red cards are there? That's going to be 52 minus 26, which of course is 26, and I'm going to select 1 of them. So it's a combination of 26 things, taken 1 at a time. The total is exactly the same, 52 total cards, and I'm going to select 5 of them. Okay, one more example. Probability of having either 2 or 3 hearts. So, 2 hearts, I would write as 2 hearts and 3 non-hearts over total. Or, which you know means plus 3 hearts. That would be written as 3 hearts and 2 non-hearts over total. Well, how many hearts are in a deck? There's 13 of them. So if I'm selecting 2 of them, that's a combination of 13 hearts taken 2 at a time. How many non-hearts are there? Well, that's going to be, I'll put this here, 52 minus 13, that's 39. So there's 39 non-hearts, and I'm going to select 3 of them over the total, which again does not change. That's 52, choose 5. Okay? Or means to add. So the second part's very similar. 3 hearts, so there are 13 hearts, and I'm going to select 3 of them. The and means to multiply, so that's times 2 non-hearts. Well, there's 39 non-hearts. I'm selecting 2 of them. and the denominator remains the same, 52 combination 5. And there's our setup for this problem.